We make decisions and choices by our past experiences. When that experience involves the Bible, we are guided by those experiences that we've had. If we believe the Bible is the narrative of God's dealing with humanity as a whole, and some more specifically with the Jewish culture and then with the Christian era after Christ, we can take comfort in the knowledge that our God is in charge. When we see bad things happening in this world, though, the floods, the earthquakes, the pandemics, which we're seeing a lot of right now, and wars, we can only make sense of this through the lens of the great controversy between Satan and God. It doesn't make sense otherwise. God has given us instructions on the care of our bodies, our minds, and our spirituality. You will be making a decision whether to avail yourself of the coronavirus vaccine when it becomes available for your age group. Some may say, well, God will protect them. And we have pictures in our mind of guardian angels, which I believe also we have guardian angels. However, I also remember the record of Christ's temptation in the wilderness, where Satan suggested that he throw himself down from the pinnacle, and Christ refused to do that. We're not to make decisions that put God on the hook to save us. I believe we have a duty to our Creator to do what we can to take care of ourselves physically, emotionally, and spiritually. Our problem is sorting through all the large amount of information that is presented by the internet, media, and print media. Some of us are suspicious of the government. Some are just afraid of the vaccine as it is so new. Some just believe they just need to be careful that the Lord will take care of them. And they can do natural things, which are good, getting proper rest, it's very important, eating properly, and some of the other things that we can do that will naturally increase our own immunity. Exercise is very important, and such things as vitamin D has been proven to be helpful if you get the coronavirus. But I believe God has provided us with information and skill needed to develop the vaccine to bring this pandemic under control. And the pandemic is, I believe, Satan's work. This evening, we have the privilege of having Dr. Danny Lewis, who's the Chief Medical Officer of Ballad Health for this area. And he also, coincidentally, is the president of the Tennessee Academy of Family Practice. And he is up to date on the latest stuff about the vaccine. In fact, he'll share a lot of things with you about that. And as one who experienced the coronavirus himself early on when it first started, he can give you some first-hand information about that too. I think that the study of the coronavirus is an ongoing thing. We don't have all the information yet. And we don't know about some of the things like the new mutant varieties and how much the vaccine's going to help those. He may allude to that a little bit. But before he begins this evening, I wanted to mention one other thing, and that is that we have the next dinner with the doctor, which is April 13th, a month from now, with Jeremy Wetmore, and he's going to talk about neuropathy under the title of I Can't Feel My Toes. And neuropathy can be caused by a lot of things, but probably the most common thing in this area is diabetes. And he'll be addressing that. And that will be a dinner with the doctor on April 13th. So let us just bow our heads for a moment and ask God's blessing. Dear Lord, we ask that you will be with Dr. Lewis and help him to make a clear presentation of the facts for us, period. Help us to review this information and make decisions using the skills that you have given us. We have the ability to make decisions, and we pray that you will help us as we make decisions about this corona vaccine. These things we ask in our Savior's name. Amen. Danny?
Hi, everybody. Good to see you tonight. Thanks for having me out to talk with you, and hopefully we can share some information. I appreciate Mike and his introduction and to talk about decision making, because we are talking about decisions that we make, in relative to the vaccine and those issues there. I will say I'm certainly not an expert in immunology or in virology or anything else. I'm a family medicine trained physician. I've been, joined Tacoma, Legacy Tacoma 13 years ago now almost, and been here in the community since. So I don't have any particular training necessarily in virology or immunology beyond that just inside my practice. But certainly have some experience with COVID-19, and for that reason, have a keen interest in some of the issues there. So, just in brief, probably most folks are aware, but about 2 weeks now, a year, 2 weeks from now, March 27th, I diagnosed with COVID-19, and so it's been almost a year. I spent 45 days in the hospital between various forms of the hospital, or ICU, medical staff, or rehab. I spent 10 days on a ventilator, secondary to the pneumonia caused by COVID-19, at a point in which ventilator survival was about 13%. So about 1 out of every 8 people on the ventilator came off at that point. So to say God was good to me during that time is certainly the understatement probably of my life. So, I'm glad to just be here in general to talk about the vaccine and those things. And if there are questions particularly about that experience, I'll tell you what I remember. There are parts of it I don't remember, thankfully. But some of it I probably do that I wish I didn't. But to talk about the vaccine in general, to kind of get out there. And with this tonight, by the way, I'll start, but please feel free. I'd prefer to have questions come up as they kind of rise, per se. So I'll try to take pauses in between, but listen, feel free to wave, stand up, shake your hands, yell, do whatever it takes, and we'll try to answer questions as we go through. But relative to the vaccine itself, we have obviously had the blessing of having vaccinations against viruses for many years. We've had multiple, since we developed smallpox vaccine many years ago with the help of Pasteur and others, we've been able to immunize against viruses. This virus vaccine is a little different, and people talk about being a novel vaccine. The COVID vaccine itself is a novel strain of the coronaviruses. Dr. Nelson, Dr. Adele, and others have treated coronaviruses their entire career. But this particular mutation was one that humans have not seen before. So it created some challenges for us, obviously not having immunity against that. And it was thought potentially that we had a new mechanism to prepare a vaccine for this using mRNA. So there's a lot of talk about the mRNA vaccines and the newness of that. And it is true very much that this is the first mRNA vaccine that has been manufactured and routinely used in the world to this point. It is not the first mRNA vaccine that's been studied, however. mRNA vaccines have been studied for the last 15 to 20 years, particularly for genetic diseases and for cancerous diseases. So the technology that is being used has been kind of in place and been used. Now, we've not developed an efficient vaccine that uses the mRNA kind of process to do so as of yet, but we knew about the vehicle and knew the opportunity. So when people say, this is a brand new developed vaccine we developed in a few months, that's not necessarily true. It was very quickly delivered and developed, and we'll talk about some of the guidance for that, but it's not necessarily new technology. We've been, I would say, colloquially playing with mRNA vaccines for multiple years, trying to develop an opportunity to do so. And what the normal vaccine, we say a normal vaccine quote, does is typically takes either a dead or an attenuated form of the virus. So the flu vaccine we get every year either uses a killed viral flu virus or a weakened flu virus in the flu mist to introduce it into our bodies so that then your body will react against that. Rather than injecting... Yes, ma'am.
Do you mind speaking from the pulpit?
No, wherever. Okay, that's fine with me.
A little bit compromised as far as the stream.
Okay, so let's go back. We'll do that. I'm not qualified to stand here, that's for sure, from pulpit. Okay, is that better? Does that flow better? Okay. So I'll kind of start back. So mRNA vaccines are not necessarily a new entity per se, but we have not used them routinely in the past. this is the first opportunity we've really had to use those routinely. So when we say an mRNA vaccine, what that means is, like I say, typical vaccines take a either dead or a weakened form of a virus and put it into a vehicle to introduce it into your body. Your body then sees that and then reacts against that. It reacts against the proteins there. The mRNA is the code that our body uses to write proteins from our DNA. So it makes a copy of our DNA using the mRNA that then proceeds through our cells out of our nucleus, and we build proteins or antibodies against that. So rather than introducing the COVID virus into our body with the mRNA vaccine, they thought they would take a certain portion of it, a certain part of its protein, and use its genetic material, which we're blessed to be able to determine through our studies in genomics, and introduce that into your cell. That helps to avoid, while we very often, those of us in medicine often fight the idea that I'm getting the virus and I got sick from the virus. There's absolutely no way you can catch corona from the vaccine because we're not introducing the whole molecule into your body. They're introducing a small portion of the spike protein, which is the protein that the COVID uses to get into your cells, essentially the part that sticks into your cells and allows it to introduce into your cells. And it encodes a small portion of that so that your body can then react against it. So essentially, the mRNA vaccine is introducing a piece of a recipe into your body. The recipe is for a small part of the protein of the virus. And then your body produces the antibody against that, so that if it does then later see the COVID vaccine, it's able to fight against that and recognize it. The novelty of the coronavirus is we've never seen this particular form of that virus before, so your body doesn't know what to do. It doesn't realize something new is in you, and that's why it can build up and take time, and why, in my case, before I really began to fight, I was sick enough to need to be in the hospital. It took 10 or 14 days. There's also then a portion of that where your body can turn against itself. We call it the cytokine storm, where it turns on inflammatory markers, because when your body gets revved up, it tries to rev up very quickly, and that also can be negative. So the thought of the vaccine is, if your body can be aware of this small portion, it can build antibodies against it, so that the first time you see it, if you get it naturally, your body can say, oh no, I don't want you to invade me, I know what to do, and it has the already built proteins against it. So that's really the difference there in how that vaccine came to be. It was a beautiful piece of genetic engineering to get to that point and to think about how to do that. And we're blessed to see that it works very well, taking advantage of our, again, God-given immune system that we have, that once we've seen an issue like this, our body remembers that, keeps a copy of that, and can then produce against that if need be. So the idea for the mRNA vaccine has been around for a while, but this is one of the first opportunities to really get into its applicability and have an opportunity to use it in a way that was thought to be effective. So we entered Operation Warp Speed, okay? And we obviously have heard that term thrown around from the government and everyone else. And probably most of you, much like myself, don't necessarily have a great trust of the government doing anything quickly and doing it efficiently. I mean, those of us in medicine know that they don't do things very quickly or very efficiently either. And to think that we're going to get both, to get them to do something quickly and efficiently, was somewhat concerning to multiples of us. So when people hear Operation Warp Speed, they have concerns about the vaccine, about how it was developed, or what shortcuts did we take to make this so fast. It takes years for vaccines to come to market in general. So just to kind of reassure you and kind of think about it, the way that I try to explain my thoughts about it is that Operation Warp Speed did speed up portions of the vaccine process. Okay, essentially, you think there's 3 different parts of the process to go through. A pharmaceutical company, much like anyone else that's going to start a business, before you start a business, they're going to look at a business plan and an idea of the need, right? No one's going to open a business here in Greene County without knowing that there's a market for it and knowing that there's an audience that would use it and that what they can produce can be taken up and used routinely. So at least you would hope they wouldn't. There may be some folks that just come up and put up a sign and hang up a business, but those folks sometimes are not very successful. So when a pharmaceutical company is thinking about making a vaccine, usually there's years of research and development to go into the idea of whether it's practical or not. They then spend a lot of time investing into the technology, which to develop what they may need to do and to go through, and then determining whether there's a market for that or not. That takes a period of time. They then have to determine what the return on investment would be. If we produce this and make this, what will be its uptake, how many people will take it, Well, what money do we have to invest on the front? Do we stand to lose, or what money do we stand to gain if we process this and make this, through? So, any of you that's opened up your own business, that's not a quick process. You take your time to think through that and everything else. I would say in this regard, this is how Operation Warp Speed sped up the first part of that process, and that the federal government essentially went to the pharmaceutical companies and said, here's a check for X million dollars. Forget about the R&D, forget about your profit. We're buying it up front. We're guaranteeing you this much money. So we want you to make something, obviously, and we need it to be proven that it will work. But here's your money up front. So essentially, it was a monopoly money given to the pharmaceutical companies. The government went to them and said, here you go, we've got it. The government printed the money just like they do everything else. Billion or trillion of dollars it was. But they said, here you go, now make it and make sure it works, potentially. So they were able to get that up front, so they didn't have to worry about the R&D. They didn't have to worry about what the market was. They were already paid. That's why people aren't charging for the vaccines now. They've already been bought and paid for by the federal government. They paid for those, in the spring of 2020 when they started this process. So they're already paid for. That allowed them also, so that allowed them to speed up another piece of it, which we'll talk about in a minute. So the first part of the vaccine would be the development thereof, which may take months or years to determine if it's needed. The government took care of that for us by saying, here's your money, we're going to buy it, produce it, and you keep the money regardless of what happens. The next part that occurs is the studies of its efficacy and its safety. And that's the part that I want to reassure you that from everything I've seen and know, that was not compromised or sped up. The company still did a small phase 1 trial where they took a few hundred participants in to prove the vaccine didn't cause harm. When that didn't happen, they then took larger studies. Most of the vaccines, Pfizer and Mrna, both enrolled, I think, 20 to 30,000 individuals across the country. Gave them the vaccines, monitored them for side effects or other issues, and spent 6 months or so taking time to make sure that the vaccines were effective, that the antibody levels your body produced did come to appropriate levels, and all of those things. Those studies were followed through. That time did not change. So typically, again, it takes time for it to develop on the front side. The trials are 6 to 9 months in general origin for most things. When we talk about medications that people come to with pills, the pharmaceutical companies talk about 3 to 6 month trial where they did this and measured numbers, whether it's cholesterol or what have you. So those things did not change. They, Pfizer, AstraZeneca, Novavax, Moderna, all the companies pledged together that they would not compromise that process. There was evidence that they held up and did the things they said they would do. For example, AstraZeneca was one of the vaccines, or one of the companies that went into the vaccine production very early, along with Pfizer and Moderna. We don't have an AstraZeneca vaccine today that's publicly available. That was because in their trial in Britain in the summer, there was an adverse effect. They paused the trial. They stopped it to hold on to make sure everything was okay. They didn't find a significant trend related to that or anything else. But it delayed them long enough that now we're talking about Pfizer and Moderna. We're not talking about AstraZeneca because it's not been approved and studied yet. So to me, that's proof that the safety process worked. When there was a concern, they paused it, they held on to it, and we've not seen that vaccine be introduced as of yet. So Pfizer, Moderna, Johnson & Johnson, another company named Novavax, AstraZeneca, all entered into this process. After 3 to 6 months, we saw pretty quickly that the Pfizer and the Mrna vaccines, which were the two studied primarily in the United States, had came to, it was doing well. We had evidence that showed they were 92 to 95% effective in preventing COVID infection at the current time. So that obviously gave everybody, not to be punny, but a huge shot in the arm. Everybody's very pleased to say, look, it looks like this is working and working well. So they went to the FDA to request approval. Now, any of us also in medicine will also know, as we talked about, the government mentioned earlier, we expected the government to be expedient about this and be fast about this. The FDA is not a fast process. It's never a fast process. They want to make sure every I is dotted, every T is crossed. They're notorious for, if something is not done correctly, if a page is out of file out of a 400-page application, they submit the application and make them start all over again, for example. You'll hear the drug companies talk about the issues they have getting things through the FDA. Because of the rapid need, the FDA chose to grant these medications an emergency use authorization. So they did take the trials, but they didn't make them submit the complete FDA application before they would allow them to be used. And that was a difference that typically is not done. All the vaccines are now undergoing the full FDA approval process, and probably, Pfizer, who we've been using now since December, won't be approved until the summer probably of this year through its entire formal process, because they will follow through that process. But they did grant the emergency use authorization. So again, with a normal pharmaceutical, we're talking about it takes months to years to develop for R&D and research and to invest in the equipment and all those things. They then have to go through the FDA, the clinical trial, which is 6 months or so, which is what they did. Then 1 or 2 years for an FDA, or 6 months at least for an FDA cycle. And then they've got to manufacture it, right? So they've got to get it approved. Most people that own a business wouldn't produce a product until they know there's a demand for it. So you wouldn't expect Pfizer to make the vaccine until they know it's been approved and they can sell it. Why would they make multiple doses? But remember, in this case, the government already purchased it and already bought it. So they were processing and manufacturing the vaccine the entire time. What did they have to lose? It wasn't their money. They already had it in there. They were already given it. And they were told, in return for this upfront payment, you have to manufacture it. So during those 6 months, Pfizer was manufacturing the vaccine that was there. That's why when the FDA granted the emergency use authorization on December 19th or whatever the day was, you saw trucks going out on the 20th, because it was already made and already produced. So I like to say that in this case at least, they shortened the front-end process with the R&D and development. They shortened the back-end process of the manufacturing by the huge investment of money they made early in the process. But the middle part, where we proved the vaccine was beneficial or worked, was not shortened and went through its normal process that any other drug or things that you may take would go through in that regard. So with that, I'll stop. Any questions about the process in that regard, to the way the vaccines kind of went through their trials and studies? Yes. Mm-hmm.
When they first make them,
yes.
how do they do the testing? Where does that stuff go to?
So with the first process, what they did initially was, again, we knew early the genetic code of the virus. So they knew they had this mRNA vehicle to put it into. So they put that genetic code into it, and they typically take about 100 volunteers to the very first start. And it's just they put out a notice and say, we're studying a new drug. They typically pay folks to do this because they wanted people to come in. And they take a small group of between 50 and 100 people, and they inject them and see. And the primary thing they do at that point is to make sure it's not going to cause them harm, to make sure there's no issue, that they don't have a significant complication or other issue related to that. And they watch those folks for about a month or so. Once they do that and they prove, okay, it hasn't caused any harm to anybody, we've done enough of them to where we feel safe with that, they then enroll the multiple people into the study and the participants. And that's where sometimes there's remuneration for that. For this, there were a lot of volunteers. Some of our local physicians actually volunteered to get the vaccine because of how significant the COVID issue was for folks. And then they divide people into two groups, placebo or actual vaccine. So you and Sharon may go in to get your study. One of you you both get shots. One of you would probably get the real shot, and one of you, 50-50 allocation, would get a placebo. They then bring you back and check your blood levels to see, are you producing an antibody against that? And what we began to see was those that had, given the vaccine had antibody levels, those that did not. And so then they followed that again. They knew that probably we need to have a booster, so they did the first shot and the second shot. They watched how the immunity curves plateaued out, how the antibodies grew out. And that's how we come to the conclusion to say we feel like immunity is granted and fully kind of attained 1 week after your second vaccination for the two-shot series. But the whole time they're also following those folks. Any complications, any issues, any side effects, anything happening to you, that you weren't aware of otherwise. That's why AstraZeneca, and again, they had someone I think passed away in their trial. Probably passed away of a heart attack or other issue, as other folks are wont to do. But they stopped the trial to make sure it wasn't related to the vaccine and delayed them in that regard. And then after those 3 or 4 months where they proved immunity not only comes up, but that it was staying up, that those levels stayed up, that's when they applied for the emergency use authorization with the FDA. So that's how they kind of went about it to start with. They initially started with some animals probably. They started with rats or something first to inject before they injected human. But they had to have a small phase 1 trial with 100 or so folks to make sure it's safe and then proceed through the other trial, typically. Did that answer your question? Yeah. Okay. Other questions about the manufacturing process and what we found? Okay. So what did they find in these trials? We kind of talked about that's how they got the process and how it got it so far. So what did they find is they found with all all the vaccines out, they had a significant effect against the COVID vaccine in preventing you from catching the vaccine. How did it do that? Well, it raised antibody levels, okay? Your body saw the protein, it generated an immune response against that, and we measure your, in quote, antibody levels. In typical, we can tell you that for the most part, vaccine-mediated immunity is stronger than natural immunity. I've had a lot of people say, well, I had COVID already, and so I don't need to get vaccinated. I've already seen it. I've already been introduced to it and those things. We can measure antibody levels of those people that are sick as well. Mine were measured, for example. While I was in the hospital, they measured mine multiple times. And they told me mine was high, at different times and different scales. These numbers aren't exact, so I'm going to, make them up somewhat. But if my high level was about 3,000, copies of the antibody or whatever else, when they did the vaccine trials, the antibody levels they were reaching were 30 to 40,000. So the vaccine-mediated immunity is about 10 times stronger than the humoral immunity. Why is that important? Well, because particularly with COVID, we think that at least your antibody levels do wane down over time. Okay, they do come down. I was part of a research study that checked my antibody levels after I had COVID in March. And actually, as I said, I spent 10 days on the ventilator, so you'd expect I had a pretty significant case of it. My antibodies were undetectable at 4 months. Okay, at least the one antibody they were checking. Now, there may have been some more research antibodies they would have tested, but as far as donating convalescent plasma, I wasn't allowed to donate convalescent plasma after 4 months because I didn't have significant levels of antibodies. And I was in the hospital for a month and a half. Yep.
What have they found of those who get the vaccine, how long the antibody levels are staying up? Because basically,
Mm-hmm.
you get the vaccine around long enough now, they get to see whether it's a lot.
Yeah. So we're starting to see that, and that's a great part of the question. So that's the thing, the million-dollar question everybody asks is this going to be a vaccine I want to get a booster? Am I going to get it every year or whatever? We don't know 100% for sure. But as I said, my antibody levels were high, around 3,000, I'm going to say 3,000 was my number, and they lasted about 4 months. The antibody levels that we're seeing in the vaccine studies are more like 30,000, 40,000. So the thought is if there is some natural decay of the antibody levels over time, then obviously the higher you start, the slower it's going to be for that to come down, correct? So you think if my antibody level stayed up from a level of 3,000 for about 4 months, 30,000 may take a year, 18 months or 2 years to come down to a level where it's not protective. And that's grossly oversimplifying it to a degree because there also is, humoral immunity, I cell, T cell and B cell immunity that your body develops. I fully believe my body retains a copy of the antibody kind of recipe against the COVID that I saw. But as far as the antibody levels circulating in your blood, we know they go much higher up over vaccine, and they seem to degrade at a slower rate or at least at the same rate as before. But again, if you're starting from 3,000 feet and you're coming down to sea level, you're going to get there a whole lot faster coming down than you would from 30,000 feet to come to sea level, right? So the thought is it'd be a whole lot higher. We don't have exact numbers yet, but 4 to 6 months later, currently, they're still very high levels.
Is there any experience with other mRNA vaccines? Are there any other is what the Shingrix vaccine, is that an mRNA vaccine?
So I'm not an expert in all the vaccines, but I don't believe it is. Harry, what's that? Yeah. So Dr. Adele asked about, do we have information about other mRNA vaccines? And from what I'm aware of, the Shingrix is not an mRNA vaccine. It's a recombinant vaccine, but it's not an mRNA vaccine directly. It's not taking the shingles code. As I mentioned, there have been multiple mRNA vaccines kind of in development over the last 10 or 15 years, particularly for cancer genetic issues. Most genetic issues are relative to an absence of a protein or something else. So, cystic fibrosis, for example, is the absence of the protein that allows for salt transport, sodium transport. If we could introduce that protein into your body and have you incorporate it, that would be a great thing. When you're having issues getting the mRNA, into the cells to be produced, versus in this case, your body has to see it and then produce an antibody against it. So, trying to change the genetic code of the mRNA is different than trying to introduce that. But to my knowledge, Mike, this is the first mRNA vaccine that's been mass-produced. They've been studying it for a while, but it's the first one that's done it. So there are some unknowns in that regard, But to this point, the antibody levels appear to come up very high, and then if they degrade, they're degrading slowly over time. We don't know 100% yet how long the immunity will last. Nobody knows for sure. Is this a 1-year shot? Is this a 2-year shot or anything else? People a lot smarter than me are trying to figure that out. I don't know that we know. The last information I saw suggested they think that the response will probably be at least a 3 to 5 year response. So, we don't know for sure, but we think it's going to be much longer than a 1 year, flu vaccine. The reason why we have to get a flu vaccine every year is because the virus mutates and uses different combinations of proteins, in its makeup. And so we have to try to cover that each and every year. Now, the COVID mutation we'll talk about briefly, but it is mutating a little bit. But as of now, we still think it's effective, and we hope the vaccine will be effective for a long period of time. What's that? Well, at least for the Pfizer and the Mrna vaccine, that was the way they promoted it. And the thought was that your body would essentially be primed with the first one to kind of have the response. And then, so the protein is introduced to your body. So your body sees it as foreign, and it says, this isn't something I'm supposed to have. It produces a little response to that. But then the mRNA is breaking down very quickly. I mean, the mRNA is only in your body for a matter of hours to a day, probably. So your body sees it and produces a response. But much like your natural kind of immunity with a cold virus, so when you're a child, children get sick very commonly because they haven't seen a lot of viruses and those things like that. Typically, as they age and as you move into early adulthood at least, you don't get sick as often with the cold, right? Why is that? It's because your body has seen a virus before and it retains a copy of that and it knows how to fight against it. So the thought about the second shot is it introduces it the first time so that you have that kind of copy there. And then when it's introduced the second time, your body goes, wait a minute, no, I've seen this before. I know I've got to produce an antibody against it. And then it really revs up that level. So in the study, they were just studied with 2 shots. That's the way Pfizer and Moderna came out, is they designed it from the very beginning to be kind of a booster, a primer and a booster kind of vaccine series. When we had concerns about getting adequate number of vaccine, there was folks that were concerned about, can we just get 1 shot and be safe? After the vaccine, the curves seem to look like, for about the first 2 weeks after your first dose, you don't have a lot of immunity. Your body's not built up a big immunity yet. Around that 2-week point, it starts to separate. You start to see the curve go way up for your antibody production. And it peaks a week after the second vaccine for the 2-shot series. So, for the Pfizer, it's 1 shot, 3 weeks later, your second shot. At 4 weeks, you kind of have your max immunity. So we see that immunity curve kind of shoot up really quickly at about that 2.5-week mark in general. We didn't study it with just 1 shot. Some people suggest that your immunity may be like 80% after just 1 shot after that 3rd week because it does go up very quickly. But we know that after 2 shots, you get to 95%. And so the thought is probably that extra 15% is worth the second shot at this point. Johnson & Johnson that's coming out is a 1-shot series. It was designed as a 1-shot, and we'll talk about its efficacy here in a minute, a little bit about it. But that's why the 2 shots, at least to start with. That's the way they were set up and studied. Other questions about that process? So what did they see, as we said, let's say, from the vaccine series? So we saw Pfizer and Moderna both put out that they had about a 95% immunity against catching COVID-19. So that out of the study groups, very few folks caught COVID at all out of the 20,000. If they split them into 10 and 10, it was like 40 people that caught them out of the 10,000 that got the vaccine. What they also saw was that those people did not get as sick as the other people that did not have it were. None of them were in the hospital and none of them died. Okay, so for those folks that did have the vaccine and caught COVID, they seem to have a much milder case than others. Again, it was 95% effective in preventing catching the COVID at the time of the trial, the time it was studied. That's an extraordinary vaccine. That's much more successful than most of the other vaccines that we have. I mean, there are years that our flu vaccine is 50 to 60% effective. There are years that it's 20% effective because we don't get the combination right. Shingrix vaccine is about 70% effective in preventing you getting shingles. We think that's a great vaccine. But if you can get 95% immunity from a vaccine, that's absolutely just amazing, unheard of to a degree. So that's what we initially saw against the initial form of the virus that was out. Now, the virus is mutating, as we talked about. You're seeing more news about variants and those things, which is why I think it's really important that we get the vaccines now while we have an opportunity before the virus makes significant mutations. There's been talk of the UK variant, the Brazilian variant. There's another South African variant that's out too now. We know that the initial Pfizer and Mrna vaccines were against the kind of initial strain that was here. is they've looked at it against the others. It still appears it's maintaining effectiveness against the variants. But as the vaccine does mutate, it is losing a little bit of that. So maybe against the South African variant, the Brazilian variant, right now the Pfizer is averaging about 70% efficacy from preventing you from getting COVID, okay? So just to put it in real terms, so a 95% efficacy means out of 20 people in this room, 1 out of the 20 may get COVID out of that. A 70% efficacy means out of this room, out of 20 folks, obviously more would get it there. 15 or 5 could get it, for example. Johnson & Johnson, people talk about it, it's been one shot, and they came out, it was like 70% effective. It's still a very good vaccine. The Johnson & Johnson was studied primarily in Brazil, where the Brazilian variant started. And at the time of the trial, the Brazilian variant was the kind of the major contributor there while they were studying it. It's about 70% effective against that one. The Pfizer and Moderna may be 80% effective against the Brazilian variant, a little bit more so, but the Johnson & Johnson is a very good vaccine in general. So what I would say is, in general, is take whichever vaccine you can get whenever you can get it. And it doesn't matter which one you get the one you can get. Because what all 3 of the vaccines that are out to this point, and you can never say everything's 100%, but to this point, I'm not aware of a death in anyone that's been vaccinated from COVID-19 at this point. So after you've had your time of immunity, after you built, your week after your second shot, no, I'm not aware of anyone seen, you can tell me, anyone dying from COVID-19 after receiving their vaccine. Additionally, there's been hardly, I don't think, any hospitalizations for people from COVID-19 after they got their vaccine. So, with a 95% efficacy, 5% of the people will catch it, but no one is going to the hospital. And to this point, no one is dying, which is a significant issue, obviously, from COVID. Its ability to spread and catch is certainly a problem, but the fact that it causes people at various stages, including myself, to go in the hospital and potentially die is what we really want to be most protective against. So all 3 of the vaccines at this point are near 100% effective in preventing hospitalization and death to this point. So in that regard, they're very effective as that would be, and go. Even as they've lost some potential efficacy in preventing you from getting COVID with the variant strains, they're still very protective against you being in the hospital or becoming critically ill or dying from the vaccine, or dying from the virus to this point. So thoughts or questions kind of about that point? Yep. Right. Mm-hmm. So the CDC, when they came out with that recommendation, again, we've not done this before, but the CDC, if you went to the website, what it said is if you've had COVID-19 or offered the COVID vaccination, you should wait until the acute phase of your illness is over, okay? So pretty much at least the first 10 days after you've had COVID, you need to wait during that phase. Once you've recovered from that acute phase of the illness, you may receive the vaccine, but you may choose to wait up to 90 days. And the reason why they said that is because, again, like myself, we think your natural immunity lasts for about 3, maybe 4 months, for the most part, after you've had the vaccine. At that point, the vaccine wasn't out very long. It hadn't came out at all yet. We don't know how long it's going to last. We still don't know that for sure. We're tracking along now 3 months. The numbers are still very high for the antibody levels, but we don't know if that will bottom off at 6 months or whatever else. So the CDC was banking on, if you have some natural immunity for 3 months, you may want to add on to the end of that additionally with the vaccine. There also was some potential concern that if you had really high antibody levels from your natural infection, maybe your body would say, well, I've already got antibodies, I don't need to make any more copies. God designed our bodies very complex, lots of things to keep up with every day. It may say, if I've already got antibodies, I don't need to make more. So the CDC thought was let those natural antibodies kind of drop down. You should have protection during that time, and also we want to make sure your body does kind of ramp up and respond to that when you get your vaccine. So the CDC actually said you had to wait 10 days for your acute illness. It didn't say you had to wait 90 days. Most folks I know waited 90 days for it. They also said that if you were in the hospital and received the monoclonal antibodies or other issues, and again, some of our treatments are giving you antibodies from other people, whether it be from the plasma or from the recombinant and monoclonal antibodies, they did want you to wait 90 days for that, again, because they didn't want those antibody levels to interfere with your body potentially making more copies of the antibodies when you did. So you had to wait 10 days. You could wait 90 days, but it's your choice. Yes, sir.
If you're on antibiotics, should you wait to the antibiotics that you know?
So there's no necessary, again, this is somewhat new for us, but there's no indication for any other vaccine that that really causes a problem. That doesn't seem to impair your body from making a copy or anything else. As we said with the vaccine currently, they have said that if you've had the monoclonal antibodies in the last 90 days, so if you're in the hospital and got that treatment, or if you got our outpatient treatment with the monoclonal antibodies, that you should wait 90 days to get your vaccine. There is some things suggesting that, even a steroid injection, so if you get a steroid injection in your knee or your hip or what have you, that you probably want to wait 2 weeks because that may impair your immune response. So I do a lot of joint injections because of sports medicine. If someone's in the middle of their COVID vaccine, I won't give it until 2 weeks after they're done. I'm telling them to hold off and wait. They've also said if you've had another vaccine, like your Pneumovax or your shingles vaccine, you should probably wait 2 weeks until you initiate your COVID vaccine. So for that, I've had a few folks that maybe were due their pneumonia shot that I've said, well, if you're going to take the COVID vaccine, hold off. Let you get to COVID first and then get that thereafter. But that's the only really kind of hold-ups they've had to this point is you can have active COVID infection, then would you wait 2 weeks after another vaccine, and they would prefer that you not take steroids in the 2 weeks before or after you take the vaccine. But antibiotics are probably fine. Yep. So again, kind of covered the production, kind of why it went out, what it did. The efficacy, it seems to be very effective at this point. Let's talk a little bit about the process and what the vaccines are like, because I hear there's a lot of questions and stories about what it does to you or whatever. So, as we mentioned, the current 2 vaccines widely available are the Pfizer and the Mrna. Johnson & Johnson just got its emergency use authorization last week. I don't believe there's any available in Tennessee yet for the one shot. Where that will be widely beneficial is that's probably, it doesn't require ultra-cold storage like the Pfizer does. So, Ballad Health has a lot of the Pfizer vaccine, but they had to buy special refrigerators to keep it in, to give it. It's not as fragile as the Moderna is. They think the Johnson & Johnson can come to Dr. Adele's office, Dr. Nelson's office, be put in the fridge, and we can keep it stable for 6 months and give it to you however you want. And it's a one-shot series. So that's going to be a great vaccine and widely available for that regard. The thought is probably that vaccine will be more geared towards kind of this middle population, 40s, 50s, and those. Those are elderly, more at high risk, if it's possible, should receive the 2-shot series because, again, we knew it was more effective probably than the other. So that's the one that's been widely available up until now, the 2-shot series, even now as they're going on. Yes, Mike. Oh.
Another thing about the one-shot vaccine is that you can give it in areas where people are not reliable enough to come back and get the second shot.
Right. Absolutely, yeah. And like I said, there are a lot of benefits to it, but it's probably not quite as effective. So we think that may be better for the folks that typically in my age range that would usually do okay with the virus. Now, I was the exception. I had the weird, had the bad case, so I got the other one. But so we know that vaccine is widely available. Tennessee started a course, like many other states across the country, with kind of the A1A population, so healthcare workers that were directly taking care of COVID patients in the hospital and had a high risk from that. Then moved into the 1AB, healthcare workers that weren't taking care of folks in the hospital, but were out in the community or things like that. And emergency responders, for folks working in group homes, those situations, those exposed on a daily basis. Just this Monday, Monday, March the 8th, they moved into category 1C as far as their tiers go. So now 1C is anyone age 16 to 64 that has a chronic medical issue, like diabetes, COPD, hypertension, obesity defined as a BMI over 30, chronic kidney disease, chronic liver disease. So widely opened up, to a much wider range of the population because a lot of folks are in that age range that have at least one complicating medical illness of some sort or fashion. So that was kind of the steps, the 1A1, 1A2, 1B, 1C. Tennessee and other states also went back and layered some age requirements over top of that as well. So around the same time they went to 1AB, they allowed it for those 75 and above. And then when they went to 1B, they allowed it for 65 and above. Now with 1C, it's gone into this, I say 16 to 64 across the board, so they've kind of backed off the ages a little bit at this point and haven't advanced any further. Their next age limit would be 55. Well, that's already uncovered now in the 16 to 64 population. So, but as of Monday, it is widely available for a large majority of the population, whereas before people had to be, okay, well, I have to have something going on to capture it. Now with the new requirements, most folks are eligible to get that vaccine. The different places it's distributed, include the health departments. So the state initially focused on the health departments as a point of application. So the Greene County Health Department has been giving it if you're in your tier for quite a while. They're now moving into pharmacies. So different pharmacies have been helping in different ways. Walgreens and CVS kind of took the lead and vaccinated our nursing home populations already. So over January, February, they went into a lot of the nursing facilities and given it to the residents and the staff of the nursing facilities. In return, they're going to get vaccine to give in their clinics. In Tennessee, I heard Saturday, Kroger pharmacies have it. I don't know why Kroger got it before anybody else, but Kroger pharmacies have it. Walmart pharmacies have it. As of Tuesday, I think I heard Ashley's and Corley's in town have it. Okay, Walgreens and CVS don't have it yet. I don't know what's happened there, but they were supposed to be, I thought they were going to be getting it first, but Walmart has it, Corley's has it, Ashley's have it. Ballad Health also has been allowed to stand up community vaccination centers again. So Ballad started giving it to healthcare workers, had some extra, so they gave it to community folks, was asked by the state to stand down and not do that for a period of time, but now I've been asked to start that again. So Ballad is giving it to any community residents in their service area. Right now they're doing it in Elizabethton, Tennessee behind Sycamore Shoals Hospital and in Kingsport at Indian Path Medical Center. Those are the only two community pods open right now in Tennessee. Now, will they branch that out and go to Greenville or other locations? They may. But right now they're trying to get them stood up in Elizabethton and Kingsport. But if you're in the category 16 to age 64 and have a chronic medical illness, you can go to the Ballad Health website and schedule your vaccine through Ballad if you choose. Like I say, the health departments have them available. You can go to vaccinate.tn.gov, or I think it's tennessee.vaccinate.gov, and schedule your vaccine online through the state of Tennessee through the health departments. Local pharmacies like Walmart, Corley's, and Ashley's have it. You can call them to get scheduled. So now suddenly there's a plethora of ways to get scheduled to get your vaccine. For the 1C category, most folks are taking your word for it. So it's an honor system. So if you say, I'm not asking Mike if he says, I'm 62 and I've got high blood pressure, I'm not checking his blood pressure before I come in. We're saying, yes, you have high blood pressure, come get your shot. So it really is an honor system. But a lot of folks fall into that 1C category. If you haven't checked it out, go look at it directly yourself to see, because a lot of folks will be in that category, even with BMI or other numbers like that. If I wasn't a healthcare worker, I lost 55 pounds from the time I had COVID to now, but I still have a BMI over 30. So I still would qualify at that age range, even after having done that. So it's not hard to qualify for the 1C. So you can access for the vaccine and get it scheduled multiple places. I think it's really important that we begin to get the vaccines as quickly as we can so that we can begin to turn the tide against this infection and really get a foothold established for immunity before the vaccine mutates. At this point, the mutations that have been developed still have some effect for the vaccine. There may come a point where that's not the case. What's really neat about the mRNA is, again, we know that it's a variant because we take its genetic code and break it down. We just have a code of so many, DNA molecules that's in the vaccine that's the active part. When we find the virus mutate, we can just take part of its genetic code and plug it into that same vehicle we have. Essentially, it's the same car, you're just going to change the key, switch it goes in. And Moderna has already started another trial with the different code for the variant vaccine, or the variant form of the virus, to see if it's effective. What we don't know is how the government, at least in this country, will respond to that. Will they let them do just like a 4 to 6 week trial to say, yeah, it didn't cause any problems, we assume it's going to have the same response, and go with it? Or are they going to make you wait the 6 months to measure the antibodies and those things again? As far as I'm aware, that's not been decided yet. But Moderna has already started another trial now to look at a more specific vaccine against the virus, the mutated form of the virus. So is this going to be a cat and mouse game, or we're going to have to give it, and then when the virus changes, change it again, or what have you? We don't know yet, for sure. We know that if we can reach about 70% immunity in a community, so our childhood vaccination series and things are still very effective, even though we have a subset of our population that don't, they're anti-vaxxers. They don't want their kids to get vaccines. We still don't see a lot of measles or mumps or things in the school system with those kids because we still have about a 93% vaccination rate in our school-age population. By studies, we know if we can maintain about a 70% vaccination rate or 70% what we call herd immunity, we should be able to prevent the virus from getting a big foothold in the room. So there's 15 or 20 people in the room here. If 14 of us have immunity, it's hard for it to spread throughout this group if it gets into this group. If there's only 30% of us had the vaccine, it's not as hard for it to spread and get out, and then for us to go out and spread it to others. So we need to get to about a 70% immunity rate. Right now, we're at about 8 to 10% fully vaccinated in the country with the age range. About 25% of the country now has gotten at least their first shot. So we expect to see that fully vaccinated number go up to 25, 30, 40% in the next few weeks. That, coupled with the large percentage of people that unfortunately contracted COVID and may be in their 3-month window, may be enough to get us, when we get 50% of the population vaccinated, we've had, probably 30%, 40% of the population have it at one point, then we can hopefully see that immunity kind of hit that 70% number, where we can see those numbers begin to trend all the way down and go down to, closer to zero. We have seen the numbers trend down fairly significantly, but they're not, at negative yet. At one point, can't recall the exact number. I think Ballad had around 380 individuals in the hospital at its highest point across the service system with COVID-19. We're at about 70 right now. So we went down from 380 or so to 70, but we've not gone below that. It's plateaued at that point over the last week or so, and we're starting to see the positivity rate creep back up. So the thought is that we kind of hit a plateau, or we're going to go back the other way. The best way to prevent it from coming back in force is to get our vaccines out there and get them rolled through as quickly as possible. So that's why I think you're seeing such a push for getting more vaccine out while we're lowering to the 1C category, and why, again, I would say probably, most people in this room now are eligible if you haven't already had your vaccine to this point. So you would have the opportunity to get it in that regard. Yes?
Can you say a word about the use of antibodies from people who have had the coronavirus, like yourself, giving serum so that
Yep.
the antibodies could be used for someone who is really sick taking the coronavirus?
So we've tried to do that in a couple of different ways, and that's the thought is, if your body isn't aware of the COVID-19 virus, can we give you plasma or antibody from someone who has, so that your body can use that to begin its fight and to see what to produce? So we've done that a couple of different ways. One is with convalescent plasma, and that's where we draw blood off someone who had the vaccine, spin it down, and then infuse the antibodies that they had into their body of the person that's sick. We've done that. We've had that available. Ballad is doing a trial for that, actually. It was funny. It started 7 days after I got off the vent. So I was too late, so I didn't get it at all. Thanks. But they started a trial for that, and then, again, the FDA gave EUA for that to allow that to be used broadly. So we did do that. We hoped that would be kind of the magic bullet. The problem was it really didn't turn into that. It was about, I'd say, minimally to moderately effective. So people that received it, some did get better, some did not. It didn't seem to have an effect in some. So it wasn't the magic panacea we wanted it to be. They then, remdesivir is another drug that they gave that they hoped to be the magic bullet, but it is about moderately effective. I mean, it helped some, but it didn't help everyone that got it. We then developed an antibody called Regeneron and bamlanivimab, are two vaccines that we got, which are outpatient infusions for antibodies, which we began to give. And they kind of shifted the focus at that point. They actually, when they came out with those, said, this isn't for the patients that are in the hospital. We're going to use this on the patients that have COVID that are at risk to go to the hospital. So those patients that are early in their disease, but before it can kind of get in and ramp up, we're going to give them this antibody to see if we can help keep them out of the hospital. I will say in general, that was pretty effective. That one did better than most. We had multiple patients that received that did it. But again, the thought is because those antibodies are within your system, we're going to wait 90 days to get your vaccine so that dies down. So there were some situations where that became a concern. One of the area nursing homes had gotten their first shot of vaccines, their first shot, and then they got an COVID kind of infection that broke out in between there, because there is a period of time until it builds up. And there was questions about, well, do we give them the antibody? Because if we do, we're going to have to wait 3 months to give the other vaccine, or do we just wait and give the other vaccine? So there were times they did that and times they did not. But that's been a treatment that we've used, but we still think your body producing your own antibodies is much more effective from the vaccine than it is from receiving somebody else's. So, yes?
Could you speak to the concerns about side effects?
Okay. Yep, let's talk that through a bit. Let me ask the question first, though, audience participation. Who in the audience has had their vaccine? Anybody had their vaccine? A few folks have. Not everybody. One or two? Okay, and some have gotten two, I know. So side effects. So there's been a lot of concern and a lot of talk about that. For the most part, to this point, what we've seen have been relatively mild, and I won't call them side effects, I call them immune response. So your body does have a response to having the vaccine. It's fairly common. About 40-50% of people have a sore arm after the vaccine. Some shots seem to hurt, some don't. Flu shot or pneumonia shots don't hurt too bad. Tetanus shots do. This is a shot that hurts. My wife got it yesterday. Her arm was aching last night. It felt pretty bad. She said it was sore to the touch. About 50% of people seem to have a sore arm with it. About 40-50% of people have a mild to moderate headache or some fatigue after the first shot they've seen to an extent. As far as more significant side effects, those seem to be incredibly rare. There's been a few folks that have had some cardiac arrhythmias. I've known a few folks that developed SVT, which is a fast heart rate after getting their vaccine. But for the most part, it's myalgias, headaches, and flu shots and things like that. I say headache, myalgias, sore arm are the most common ones we've seen, most commonly. Some people have some GI distress and things, but that seems to be pretty limited. Now, for most of the population, that's after the first shot. After the second shot, again, your body's seen it before, remember, and it's kind of primed. So people have had a more robust kind of immune response after the second shot. I've heard multiple cases of people 12 to 18 hours after their shot having a low-grade fever, up to 100.4 or so. I've heard of a couple of occasions higher than that, but usually about 100.4, 100.6. Myalgias, aches, feeling pretty bad, having to go to bed and rest for 8 to 12 hours. Most folks, after they've taken a nap and after they rested for 8 to 12 hours, feel better after that second shot. They do advise that they would say, the preference would be you not take a lot of antipyretics for that unless it's really bothering you, so Tylenol or ibuprofen. So we try to limit that. You can take Tylenol or ibuprofen if the symptoms are severe. We'd prefer you take Tylenol instead of ibuprofen because ibuprofen is an anti-inflammatory. And the thought is we don't want to dull that immune response at all. So in general, we say try not to take Tylenol or ibuprofen, but if your symptoms are severe, you can take it and have it thereafter. So for the general population that haven't had COVID, after shot 1, a sore arm, a few headaches, muscle aches, after shot 2, maybe 20-30% of people feel pretty bad for about a day or so. So they've usually said if you're taking your second shot, plan to have the next day off work, don't have anything scheduled you've got to do or get done because you may not feel like it. You may feel pretty bad, and you may need a day or so to rest. That's not really a side effect. That's your immune response. That's your body saying that it's ramping up and it's evidence that things are going well. Now, conversely, if you don't have that response, it does not mean you're not producing the antibodies. I've heard some people say that. I didn't have any problem. It doesn't mean your body's not producing the antibodies. It just means it wasn't real robust and didn't get up real high. Interestingly, several folks like myself that had COVID found that they had a reaction after the first shot. So I will tell you just my story. When I went to get my vaccine, I was infected March 27th. I got my first vaccine December 29th, so it was 6 months later. I sat down in the chair. I got my vaccine. And at Ballad, they would monitor you for 15 minutes if you never had a problem with the vaccine or anything else. So the time I got up until the time I walked to the chair, my heart rate was 125. As soon as the needle got out of my arm, my body went, I remember this. And it ramped up and turned on almost immediately. I was fine that day. I felt a little foggy. Some people talk about a COVID fog, but their mind was a little bit foggy. I felt a little foggy the next day. On day 3, I had a pretty severe headache, and I had to go to bed. I left work about 4 o'clock and went home and took a nap and felt better. By Tuesday, I was fine. My shot was Saturday. I was fine on Tuesday. I was a little concerned about getting the second shot because I was like, my gosh, if it did this to me after the first one, what's it going to do to me after the second one? I had no issue. I took the second one. Nothing happened. I was fine. So you talk about the 2-shot kind of series. It's looking like everybody needs a primer and a booster to kind of respond. So you have to be introduced to the virus, and then you get your response with the second shot. For those that never had COVID, that's your first shot and your second shot. For those that had COVID, it's probably the COVID infection is our primer. Our body remembers it, and like I say, with that first shot, my body said, no way. We're not going through this again. And it turned on immediately. I heard multiple people say that had COVID, that said after their first vaccine, they felt like they had COVID again. It's actually the point where we've actually said for some folks, it's kind of a screening tool now, because if you react after your first shot, we've been telling folks, you probably had it, you were just asymptomatic. We know there's a percentage of people that had COVID that were completely asymptomatic and we didn't know. And so it's actually probably a more accurate test to measure your antibody levels to see if you respond to the first shot versus the second shot. It's still important you get the second shot. You want to make sure you finish the series because that's what we know is most effective. So I went back and got the second one. I asked a couple people about it because, like I say, I was one of the early ones to get the vaccine. I got it 5 days after it because of my experience I had after it came out. But I've seen multiple other people now that had COVID. So all I would say is if you know you had COVID, prepare maybe to feel bad after shot 1, and just for that if you can. And then shot 2, finish it and go through and be fine with it. Most people do really well. It's really not that big of an issue, but some people don't feel real well after that first or that second shot. There, again, we're kind of studying and walking through. There's been, I think, 3 cases I know of worldwide with thrombocytopenia after the vaccine. So there's been 3 episodes that I'm aware of where it looks like people's platelets have dropped. There is a story of one physician in Florida that got the vaccine that developed immune thrombocytopenic purpura, or ITP, after the vaccine, and he had a stroke, and unfortunately he passed away from his stroke. We don't know that that's related to the vaccine because actually the rate of ITP we're seeing with the vaccine population is less than just the risk of ITP in the general population, just iatrogenic ITP. So out of 100,000 people walking around in the U.S. in a year, 10 people out of that group will get ITP during the year. Our rate right now with the vaccine is about 1 out of 500,000 or greater, maybe 1 out of 1 million to this point. So it's not been around long enough to be correlated. I have heard of 3 episodes of ITP that's maybe related. One person passed away from it that I'm aware of. The other 2 I don't think did, from what I know. That's, again, just coming out in the last week or 2. I've heard about that a little bit. So that seems to be the most significant, quote, side effect that I've heard of and not aware. We're up to about, in this country, 3 million vaccines I think have been given or more now at this point. That's 1 death. We've had 500,000 deaths otherwise from COVID. So certainly there's a huge risk of death, much greater from probably the natural infection than anything related to the vaccine that we're aware of. Over time, we may find out more. We'll see. But as of now, I would 100% recommend that people get the vaccine. Obviously, I took it. My wife got hers Monday. My brother gets his tomorrow. My mother-in-law, father-in-law get theirs Monday and Wednesday next week. My dad got his to VA 3 weeks ago. So everybody I have a relationship with, I'm trying to get it. So I think you had a question first, and I'll come back. Mm-hmm. I don't know that we know that yet, and we'll have to wait and see. I think we'll get some more science about that. Chances are these groups will continue to produce these vaccines. Moderna is entirely a vaccine company. That's what they were. Actually, when Mrna, their name, M is for M, and Mrna is RNA. So they've been producing mRNA vaccines and been doing this for several years. So there's no chance they'll get out of the market, I don't think. Pfizer will stay in, Johnson & Johnson will stay in. So chances are if you got the Pfizer vaccine now, 5 years from now, will you have the opportunity to get the Pfizer again? You probably will. Will you have to? I don't think we know yet. They're using the same technology, so I wouldn't think you'd have to. I think, in 5 years, if you had Moderna out and you could get that and you had Pfizer before, that's probably okay. But again, just trying to stick to the evidence and the science, which again, is reassuring to me because we're trying to stick to the science as best we can. Everybody in the trial's got 2 of the same one. So we're not going to go mix them up now to see what happens. We're going to let you get 2 of the same ones. There probably will be trials about if we have to have a booster, mixing some people in between those groups and seeing what happens. But yes.
The odds of the virus vaccine being the same 5 years from now is not that high.
Probably not. Probably be some changes to it, yeah. And again, the thing that led to this one being so different is just that the combination of the proteins this coronavirus had, we'd never seen before, so we didn't have a response to. You could probably guess, eons ago when the vaccine that now causes the common cold, it's one of the coronaviruses, when that first came out, it probably devastated the population that went through. We think about smallpox and all those things. With the Indians, we talk about the Europeans and how smallpox decimated the Indians. It may have been smallpox. It may have been the common cold. They may have never seen it before. It may have been isolated in Europe, and when it came through the Indian population, it may have been a virus that devastated them. 100 years from now, this COVID-19 strain we'll all have seen and been immune to, and it'll be like a cold. We'll get the sniffles and everything else, and our body will be like, no, I can fight this off. But just right now with its newness has been the issue. 5 years from now, it's not going to be the same. Will there be COVID-27 at that point? We don't know. But we certainly think we can take the lessons we've learned from this process, and we've proven this vaccine technology is appropriate for this. And I think, again, we're blessed to live in an environment now where we had the genetic code of the COVID virus, well, at least China had it as soon as it was available. Within a month of it being in the United States, we had the code of the vaccine that was in Washington State that we isolated and we knew its genetic code. So in the future, if we can knock out the code and put it in the vaccine, we could probably mass produce this and get it going a whole lot faster in the future. Yeah, Mike.
One of the interesting things is that the side effect, one of the major side effects on people who get the coronavirus is that they become hypercoagulable. And interesting that side effect is that you don't coagulate enough from the vaccine. It's kind of strange that that's
It is. And again, I don't know that we know everything about it yet. I will tell you that I know all about the hypercoagulability. I had multiple pulmonary embolisms. One day while I was on the vent, my number shifted significantly. I had to go up my oxygen and everything else, and that was the day probably where they told my wife they weren't sure I was going to live. We found out 2 weeks later I had multiple pulmonary embolisms in my lungs. So that's probably the day I threw the PEs while I was on the vent, and they didn't realize it. But we did learn quickly that it does cause hypercoagulability. But yes, we have seen a few instances of thrombocytopenia. So 3 now out of 30 million shots or whatever. So it's not a huge number at all, and we don't know what to do with it yet, but we're trying to get there. What other questions you guys have about the vaccine? Yes, ma'am. Yes, ma'am. Yeah. And the problem is, and the reason why for that is because we know that those things seem to increase your risk from the COVID significantly. Okay. Again, and we don't practice anecdotal medicine. We do things based on studies, but obviously, having lived through it, my blood pressure was a little high and my BMI was a little high. I weighed about 243 pounds the day I was infected. I'd been up to 260 before that. I'd been working on my weight, but I was 42 years old and otherwise pretty healthy. Exercising, I was walking 2 to 3 miles a day, 2 to 3 miles 3 to 4 times a week, lifting weights with my son, doing other things. I actually was probably in better physical shape in 2020 than I'd been in the last 5 years previous to that. And it darn near killed me. Most of the folks that we see have significant complications have existing either obesity, heart disease, or COPD. That seem to be the most significant factors. It's really strange. We have some people with severe COPD that breeze right through it. They don't have any issues whatsoever. I mean, we've had 93-year-olds in the hospital, on hospice with COPD that I take care of that get it, and 10 days later, they're fine. It's no problem. Their oxygen never dropped. They never coughed. It's amazing. But we do know that those that have those chronic diseases are certainly at risk, which is why we're moving so much now. We did the age, and we know age also is a risk. We know your risk of mortality goes up significantly with age, which is why the state overlaid those age restrictions. But now that's why they've opened up to those, like I say, 16 to 64 with a chronic medical issue. Hypertension, heart failure, diabetes, all those things are mentioned in there, as is COPD and others. But really, any chronic medical issue that puts you at risk is you're eligible to get the vaccine. So I would suggest that you do, simply because if you have those issues and you contract the vaccine, there's a much greater statistical likelihood that it will cause issues for you after the fact. We also have multiple folks that even after they have COVID, some that had relatively asymptomatic courses are having symptoms months later. I was blessed in multiple ways. I had a very significant front-end course of it. But to this point, I don't have any significant issues with lungs or fatigue or everything else. I'm really back to work, doing everything back like I was. It took about 4 months from the time 4 to 6 months to recover, but I don't seem to have any long-term issues. I've had other friends that had relatively mild courses that are still having significant issues with their lungs or heart or other areas there. So it certainly is important that I think, we know those things predispose you, so certainly you should get your vaccine if that's the case. You'd be hard-pressed for me to find anybody that I'd say shouldn't have the vaccine, though, unless you've had an anaphylactic reaction to another vaccine. And even then, I say get it. Just make sure you're somewhere. That is the other issue, too, and I'll come right back. But there was a concern about anaphylaxis of this vaccine, people being concerned about having significant allergic reactions. We know that, based on numbers, you're about 10 times more likely to have a significant anaphylactic reaction to this vaccine than you are to the flu vaccine. Okay? Yep. Oh, thank you. Yeah. I'm lucky. I've done really well. But we know you're about 10 times more likely to get anaphylactic reaction to this vaccine than you are to the flu vaccine. So everybody goes, that's not good, okay? It's still about 1 in 125,000 at this point for an anaphylactic reaction to the COVID vaccine. It's about 1 in a million for the flu vaccine. I would contend I don't want to be one that has an anaphylactic reaction at all. But because we know that risk is there, everyone that's administering it has to have the equipment available to be ready to be prepared for that. So when you go to Ballad Health or whatever else, they've got the Epi kit and everything else laying out there. Anaphylaxis is not a fun thing. You don't want to go through it. But anaphylaxis is dangerous when you don't recognize it and you don't have the stuff available for it. Everybody given these vaccines has been trained to look for it, and they have to have the stuff available or else they don't receive the vaccine to give it. So I would contend you're safer getting that vaccine in those situations, even with the higher risk, than you are getting a flu vaccine in my office. Because we have epinephrine in my office, but it's in a vial over there, and we're not thinking about it. We're not really concerned. And if Mike starts having trouble breathing, the first thing my nurses are going to do is freak out, number one. And number two, we got to find the epinephrine. We got to break it and draw it up and do all those things. So there is an anaphylactic risk. It's very small. I don't know of anyone yet who's had that reaction. Everyone is there ready to be trained. That's why they make you wait 15 to 18 minutes. All the cases we've seen have occurred within 18 minutes of getting your vaccine to this point. So you wait for 15 to 20 minutes. If you've had a history of anaphylaxis, you wait 30 just to be safe. And they are there and ready to treat it if necessary. So I don't want you to be the one that has to be treated, but if we recognize it, we can very quickly, the treatment for anaphylaxis is epinephrine. As long as we have epinephrine, we can treat you and you'll recover. You may stay in the hospital overnight potentially to be monitored, but you will recover from that. Where I can't say the same with COVID for, unfortunately, 500,000 folks.
Thank you, Dr.
Yep.
Lewis, for giving us all that good information.
Yep. And I don't mind if anyone has, I'll stick around for a few minutes. If anyone has a question you didn't want to ask in the group or anything, feel free. I'll be glad to try to answer it best I can, as everyone do. But thanks for coming out, and I appreciate your consideration. And I hope everybody goes and gets their shot.
Gracious Lord, you are such a great and loving God, and we love you, and we want to serve you, and we're so thankful that you have provided this information for us. We pray that you will go with us, help us to be safe, and to serve you. In Christ's precious name we pray.